Good morning, everybody. My name is Monica. I'm working as assistant professor in VNR BJT. Today, I'm here to discuss one of the most important and interesting topic called Hadoop. In this lecture, we will see what is Hadoop and architecture of Hadoop, and what are the components do we use in Hadoop. First of all, let us see where do we use Hadoop. Hadoop is an open source framework that is used to store and process large data sets like big data and all. The sizes can be from the gigabytes to petabytes. Instead of using one computer to store the and process the data, Hadoop allows multiple clusters, multiple systems to store the data. Because nowadays the data storage is not that cost effective. We can store it in many disks. We can replicate the data easily, so that if there is any loss of data also, we can get back it very easily. So we can store it in many multiple systems to process the data. The processing of this data will be done very easily when we use multiple systems. Why do we need to use Hadoop? Because first point is scalability. Because nowadays the data, let us take some online shopping called Amazon. In this Amazon, we'll be having some petabytes of data or even more than that. So we cannot store that complete data in one system. We cannot process the data at a once. So we'll be storing with the thousands of computing nodes. We can store it in thousands of machines, and it is. And the second point is cost effective. It runs on low commodity machines also. We can use our machines also to run Hadoop. And it is efficient because by distributing the data, Hadoop process the data in parallel nodes where the data is located. We can get back the data, we can extract the data, we can load the data very easily. And actually, what is Hadoop? Hadoop is an open source platform which is used for distributed computing that we already discussed. Hadoop processed both unstructured and the structured data. Structured data can be in the form of some word, or some semi-structure can be in the form of XML data, and the unstructured data will be in the form of some pictures, videos. For example, let us again consider Amazon only. In Amazon, while shopping, we will be seeing images. Those images will be stored in their formats. We can even process that images also. For image processing also, we can use Hadoop very easily. And this is a low cost framework. We can access with any system in any commodity machines. We can use it in any clusters. With a we can scale up from single servers to multiple. uh, Multiple means thousands of machines or hundreds of machines, each offering local computation and storage. Now, in introduction to Hadoop architecture, let us now see what the Hadoop architecture is. In this Hadoop architecture, we'll be having an application database. From that application database, we'll just see what do we want and what do we need to process and all, and we'll just load, extract, transform and load the data into the data warehouse. In the data warehouse, why do we use data warehouse? The warehouse in the sense the storage, where we want to store our data and all, and from the data, whatever the data we want, we just extract from the data warehouse. And this Hadoop uses some of the techniques called MapReduce. Is one of the technique that we use in Hadoop. And like MapReduce, we'll have Hive, Pig, Scoop, Flume. We'll be using different components. Each component of the Hadoop has some different scalability. It has some ability to do the different task very easily. And this is the Hadoop ecosystem. In this Hadoop ecosystem, we will have all this Flume, Zookeeper that is used for data management, Hive for data access, MapReduce for data processing, HDFS and HBase is for we use for data storage. HDFS is nothing but Hadoop distributed file system, where we distribute our files in the systems. These are the Hadoop ecosystem that we already discussed in the previous diagram and all. Use case of Hadoop, uh, to aggregate the data in our mobile phone only. We aggregate the data by using some of the techniques called called search by date, search by time and all, so that we can aggregate the data easily. To give the exact data context, in the social networking sites, for collaborative filtering and all, to keeps apps running, weblog system logs, we use them to deliver mashup services like mobile data locations and all, clickstream analysis, and we can use sentimental analysis for we mostly use Twitter sentimental analysis, to see whether that Twitter is we can see that there are we can filter that they are giving positive thoughts to the tweet or the negative thoughts. We can filter the data very easily. And Hadoop server roles. In these Hadoop server roles, we'll be having distributed data processing and distributed data storage. In that data processing, we'll be using the technique called MapReduce. In data storage, we obviously store in HDFS, because it is a Hadoop distributed file system. In that MapReduce, for processing, we use a called job tracker, name tracker, and all. And in HDFS we use the name node and secondary name node. Those are called masters. We'll study in the next slides and all. Because this job tracker will assign the job, this name node will store the metadata. Metadata in the sense data within the data. This data node will have the connection with other data. The data will be stored in name node. Assumptions and goals of HDFS. HDFS for high throughput access to application data. HDFS uses master slave architecture. We already said that the data will be broken into some small pieces based on the size which we want. And what they do is they just send the small amounts of data to the data nodes, and we'll replicate the data. By replication the data, if there is any loss of data also, we can get back it very easily. uh, we use the technique called fault tolerance. If there are any loss of data also, we can get it back very easily. And this name node is the master node, because it keeps track of all the data nodes. If there are any loss of data also, and the first name node will check where the data is lost and how to retrieve the data and all. This is HDFC architecture. As we said, HDFC architecture will have the name node and the secondary node. Name node will have the data called FS image and log files and all, and the data of the name nodes, and the location of the name nodes, and the replication factor of the name nodes and all. What is name node? It keeps, as I already discussed, it keeps all the metadata of files blocks in a file system and tracks the cluster across the file data. It Name node actually does not store the data. It just it just distributes the data. It just have the location and the log files of the data where the data. The client server talks only to the name node. Like in any administration, the client talks only to the like HR manager. Like somebody, HR manager will assign tasks to the juniors. So that is what happens in this name node. This name node sends heartbeats to the data node. Every 10th heartbeat is known as block report. They just note down the what is the block report. We use that TCP/IP protocol in this to to have an efficient connection. We use this TCP. And one more thing is, if name node is down, HDFS is down, because we cannot replicate the name node. We just replicate only the data. We cannot replicate the servers and all. If name node is down, HDFS is also down. What is data node? As I already said, data node stores the data in the Hadoop file system, and it has more than one data node with replication. I already told replication factor can be 3. A client talks only directly to the name node. Secondary name node. If there is a fail of name node, we can find the not the exact location, but we can find the traces of the name node, where it has lost, how it has lost and all. Data replication. this is one of the most important concept in Hadoop because we replicate the data, because the disk storage will be high, it is cost effective. We can replicate the data as many times as we want. As Hadoop is designed with large scalable and distributed data, so we replicate the data. If there is any hardware failure or software failure or network partition also, we can replicate the data, and if there is any loss also, we can get it back by using the concept called fault tolerance. I already discussed. Replication factors, how many times we can replicate the factor, how to create the replication factor, and while replicating the data also, no same data will be there in the same rack. That is called the concept called rack awareness. No same data will be there in same rack, it will be in other one. And in the same way, the other data will be in other machines and all. One replication resides in current node, one in the other node, and one in the, and as it is a factor of 3, we can replicate in 3 other nodes also. See, I already said rack awareness. See, here in this diagram we can see we have replicated the data in racks of 3, and there is loss of one data. But this name node, this rack awareness has given the instruction to the name node that there is some loss of data, you please replicate, you can take the data from this rack 1 or rack 2. So that we cannot nowadays, with the one of the most important thing we have to be very secure is the data. Because of that data, there will be many problems outside. So in order to uh, in order not to lose the data, we use this rack awareness. If data node failure, no problem, we can get it back easily. Data nodes always send the heartbeats to name node. If there is any failure in heartbeat, no problem, name node will rectify that problem in the data node, and it will send the heartbeat. A heartbeat in the sense, it just justifies the health of the data node. See, this is the heartbeat and re-replication. Re-replication missing the heartbeat, we can signify the lost nodes. Name node, as I already discussed, name node consults metadata. Name node consults rack awareness. Name node tells a data node to you please replicate your data. Name node failure. And name node is a single point of failure in a cluster. Because of, if we think that we have lost the name, yeah, first thing is just restart the machine, we can get it back. Otherwise, we need to go to the secondary name node and get back the metadata and all. Apache, and one of the most important concept in Hadoop we use for processing is MapReduce. In this MapReduce, what do is we just schedule the task, we just shuffle the task, and we just sort it out. This MapReduce is mainly used for word counts and all. Even if there is 1,000 of lines, 10,000s of line also, we can count the data very easily. The word count, we can do it very easily. We can store the data easily. We can shuffle the data very easily using the concept called MapReduce. See, in this MapReduce, this all these records are the input data. In MapReduce, we'll be having two concepts called mapper task and the reducer task. In this map task, we'll be having key value pairs. All these records will be having the key means the record. If suppose let us consider the first row, we can say it has the value of 1, and the value may be record, it has a value of 2 and a value record and the number 2, so that we'll have the key value pair. Because after shuffling the data, we don't need to search the entire input and all. And in reduce, we'll do sorting and all, and we'll be getting the like data together in the output. Map task. Map task is to run your computation on your local data machine only. Reducer task will run according to the map task, because in mapper task only most of the work will be almost done. Sorting, shuffling, everything will be done in map task only. See, for example, let us understand this map reduced processing technique by using this example very easily. Here, the input data is dog, cat, rat, and the next one is car, rat, dog, car, cat. So, we just need to find how many times the words are repeated. First, what do? We just split the data. After splitting in mapping, what do we do? As I already told, we'll be in map task, we'll be using key value pairs. This is the key and this is the value. So the dog one, cat one, rat one, according to the given input data, we'll be doing key value. And the shuffling data, shuffling means all the like data will become in the one record. Every suppose see here, all the dogs from the input data has come together, cars from has come together, cat, rat, and has reducing. This reducing will do the word count. How many times the dog has repeated, how many times the car has repeated, likewise the cat and rat. The final result will be the word count of the given input data. If we want to do word count only for the prescribed data, what data we want, we can give it directly in the Hadoop ecosystem. Job tracker. So in this map reduce and we'll be using job tracker and the map tracker. Job tracker is for submitting a tracking map reduce jobs in Hadoop. Job tracker will just perform the actions in Hadoop. It accepts map reduce jobs, talks to name node, locates the task tracker. Task tracker will be there in the reducer task. Submit the work to the task. After the completion of shuffling and all, we'll submit the job to the reduce. You please count the words. We need these words. You please count it. We'll tell to the reducer. See, in task tracker, we'll accept what all mapper sends the data. We accept it. We just reduce, we just shuffle, and we do the operations what are assigned by the job tracker. We just set some slots and all. Task tracker notifies the job tracker about the job success status and all. Uh, Thank you guys. This is all for the today's session, and the next video we'll be discussing how other concept. We'll be discussing in detail about what is map reduce with some we use background, we use Java. With that we'll discuss what is map reduce in detail and all. Thank you for your time and consideration. Thank you all.